a normal line is just perpendicular to a tangent line. So for example, if I have a curve and my tangent line right here is that, my normal line is just perpendicular to it. So that would be the normal and that would be the tangent. So the only change is going to be surrounding what? The slope. So whatever your slope is of the tangent line, your normal line is going to have an opposite reciprocal slope, and that's all there is to it. So find the equation of the normal line and the tangent line at the given points. So at 0, 3, we're going to do this one first. We have the point. We need the slope at 0, 3 to write the equation of the tangent line, and then we'll flip that to write the equation of the normal line. So to start, we have to find the derivative. They want us to do it twice. We're going to have 4 lines here. A normal and a tangent here, and a normal and a tangent here. So x squared plus y squared equals 9. What's the derivative of that? Connor. Forgot something very important. So when I solve that, dy over dx will be negative 2x divided by 2y, which is negative x over y. So my slope at 0, 3 is what? 0. 0, negative 0 over 3 is 0. So my tangent line, I'm just going to be organized so I know what I'm doing. Tangent line is y minus 3 equals 0, x minus 0. What does that simplify down to? Y equals 3. And our normal line, what slope are we going to use? What's the reciprocal of 0? Undefined. The reciprocal of 0, and the reciprocal of 0 is always undefined. So undefined lines are what kind of lines? Vertical, which run by the equations x equals whatever point, x coordinate we have to go through, x equals 0. Okay? So in hindsight, what is this the equation of? A circle centered at 0, 0 with a radius of. And so we just found the equation of the tangent line at this point, which is obviously y equals 3. And the equation of the normal line right there is x equals 0. So we could have done that one without actually doing this process. 2 root 5 we'll have a tougher time with. So 2 root 5 is somewhere out here. So we have our point. Our slope for 2 root 5 is going to be negative 2 over root 5. So our tangent line there will be y minus root 5 equals negative 2 over root 5, x minus 2. Our normal line there will be y minus root 5, same point. We're flipping the slope, so root 5 over 2, x minus 2. So the tangent visually would do this. What did I do wrong? Liam? No. Winter? Right. I forgot to do the opposite reciprocal, so it should be positive 5/2, which positive root 5 over 2, which I realized because I was about to draw the normal line and it should have a positive slope. It might have a negative slope, so I kind of realized that. Good. Is that okay? So just a new if you see normal line, that's all that means. It's not anything crazy. All right. Write the equation of the tangent line to the graph at the given point. Okay. Derivative. Help me start this, Haley. Good. Equals. Zach, pick up for me. Yep. Mm-hmm. It's minus. Okay. You also forgot something else to close out the quotient rule. Good. So if I want to solve for dy dx, I'm just going to divide this 2y over, which is just going to throw it in the denominator over here, yes? So I already have my point. My slope, I actually have to come up with, and be careful here, 2 squared plus 1 minus 2 minus 1 times 4, 2 times root 5 over 5. I'm going to avoid making a mistake, hopefully, by just plugging in now. 4 plus 1 is 5, minus 4 times 1 is 4, over 2 root 5 over 5 times 5 squared is 25. So that 5 and 25 reduces, such as 1 over 10 root 5. And now we're ready to write. Y minus root 5 over 5 equals 1 over 10 root 5, x minus 2. Okay. They might get rid of the complex fraction. Oh, it's not even a complex fraction. They might get rid of the fractions by multiplying both sides by the least common denominator here, which would be 10 root 5. So if I multiplied both sides by 10 root 5, I'll get 10 root 5y. This 10 root 5 times this term, the 10 and the 5, would just become 2 root 5 times the root 5 that's there. You follow that? Take a minute to digest that. 10 root 5 times root 5 over 5. This 10 and the 5 would reduce to 2. And then it would be 2 root 5 times root 5, which is 2 times 5, which is 10. And then this 10 root 5 would just cancel that, and it would just equal x minus 2. The only other thing I could envision is like standard form, so they might subtract the 10 root 5 over. And add the 2 back over to the left. I'm sorry, I said it wrong. I did it differently. I subtract the entire y term over. And I can't remember if this is the spot. I haven't looked at the answers in the back of the book, but there's a place where sometimes they write the equation of the line like this. And they literally put everything on one side and have it equal 0. So if you could see that. I've never seen that format before. It doesn't like have a title in math, as far as I know. But they do sometimes have the answer in the back of the book like that. At least they did in the old textbook. This is the new textbook, but it is the same writers. So you'll just have to... That's really all I can envision. Last one. Find the points... Oh, I forgot to put this example down. Find the points at which the graph has vertical or horizontal tangent lines. So the equation here was supposed to have been 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So we're looking for the points at which the graph has vertical or horizontal tangent lines. So our slope needs to equal what? 0 to make the horizontal tangent line, or undefined to make the vertical tangent line. Correct. So we're going to first find the derivative. 8x plus 2y dy dx minus 8 plus 4 dy dx equals 0. I'm going to add my 8 over and subtract my 8x and factor out my dy dx and divide it over. So back to the concept. If we have a vertical tangent line, our slope needs to be undefined. What value would make this undefined? But be more specific about what needs to equal -2. The y coordinate, if the denominator is 0, then we have a vertical tangent line. So that would be a y equaling -2. So as far as the coordinates are concerned, we have the y coordinate of one of our points. What is the x coordinate that goes along with a y coordinate of -2? Or how do you find it more? Because, Liam? Yep, you go back to the original. So at a y coordinate of -2, we're going to go back up here. 4x squared plus -2 squared is 4 minus 8x plus, or 4 times -2 will be a -8, plus 4 equals 0, and we're going to solve for x, which plus 4 is 8 minus 8. Those constants will cancel, so that's lovely. And then we can just solve by factoring out of 4x. We're left with x minus 2. So that's either at x equals 0 or x equals 2. So there's actually 2 points where we have a vertical tangent line. Zero -2 and 2 -2 for verticals. Horizontal tangent lines come with a slope of 0. So for this slope to equal 0, the numerator needs to equal 0. So what would x have to equal? 1. So that gives us the x coordinate. We're searching for the y. We're going to go back to the original, plug in an x of 1. So that'll be 4 plus y squared minus 8 plus 4y plus 4 equals 0. We have the same lovely situation with 4 plus 4 being 8 and the minus 8 canceling. So we can factor out a y. And there's also 2 locations where this happens. Y equals 0 or y equals -4. So 1, 0, 1, -4. Questions? We have to hold on. You can't just trust me, can you? No, you can't. I can't even trust myself. I've got to prove it to myself. Anyone know what shape this is? You think so? Okay, so I'm going to do this. This should remind you of Algebra 2 and geometry. See what I did there? Got my x's together, got my y's together, brought my negative 4 over. Good. I'm going to complete the square on the y. Half of that is 2, squared is 4, so I'm going to add 4 to both sides, and that's going to turn this guy into y plus 2 squared. I can't complete the square on this one just yet because of y. So now, what do I add in here to complete the square? Right? Half of this is negative 1 squared is 1. What do I have to add on the other side to counter that? 4, because this is technically a 1 times 4, so if I add 4 to the left, I have to add 4 to the right. So this ends up being not a circle, but an ellipse. Because if these are ever not the same coefficient, then it's not a perfectly round circle anymore. It's been like pulled this way or pulled that way. Does that make sense? Okay? So what you'll see when it's an ellipse, what they'll do is it always has to equal 1. So the equation would, this is really the general format, which you've never learned. This is technically over 1, and this is equal to 1. So this tells us that it's being pulled. God, let me think of how this is. I think it's being pulled along the, I'd have to remember. I think because this is 4, it's being underneath the y, it's being pulled along the y-axis, so it's a vertically oblong ellipse. At any rate, we're going to look at it by solving for y, because we're going to type it into the calculator. So I'm going to subtract that over. I'm going to multiply by 4 to get rid of that denominator. Y plus 2 equals, plus or minus, that whole big thing, and then I'm going to have to subtract 2 at the end. Race against the clock. I'm excited to see if I remember this correctly or not. So I have to type in y equals the square root 4 parentheses 1 minus another set of parentheses x minus 1 squared, close that parenthesis, get out of the brackets, minus 2. And I have to do negative of the same thing, square root of 4, 1 minus another set of parentheses, x minus 1, close, squared, close, get out of there, minus 2, zoom, 6. Please be stretched, yes. You see? The center is still at 1, negative 2, so your circle center, HK, is still a property here. Our center's at 1, negative 2, and it's pulled vertically. Wait for it. Don't move an inch. Most importantly, what did we just find on our notes? We have vertical tangent lines at 0, negative 2, which is the left side of the ellipse, and at 2, negative 2, which is the right side of the ellipse, and horizontal ones at 1, 0, which is here, and at 1, negative 4, which is there.
Good job.
That was so much fun. That's a whole chapter in Algebra 2 that New York State doesn't think is important. Ellipses, hyperbolas.
I think teaching us how to do our taxes was kind of important.